worldwideweb.com/doc/tutorial/ntcs/ Learning C++ by listening. Part 11. Character sequences. A learn by listening exercise. Open parenthesis. If you haven't already seen or heard the previous chapters in this series, you should do so before proceeding here, as it will help you understand the context and unusual format of this presentation, which is optimized for listening so that you don't necessarily have to watch the video. Close parenthesis. In prior sections of this tutorial series, the double quote, string class double quote, has been briefly introduced without a lot of fanfare. It is a very powerful group of tools to handle and manipulate strings of characters. However, the C++ string class was built up from lower level features based on character sequences. Strings are, in fact, sequences of characters, and we can always go back to the low level tools to represent or access them also, as plain arrays of elements of a character type. For example, the following array. Char foo, left square bracket 20 right square bracket, semicolon, is an array that can store up to 20 elements of type char. In memory, it is just a named section of RAM big enough to store 20 characters adjacent one another. Therefore, this array has a capacity to store sequences of up to 20 characters. But this capacity does not need to be fully exhausted. The array can also accommodate shorter sequences. For example, at some point in a program, either the sequence double quote, hello double quote, or the sequence double quote, Merry Christmas double quote, can be stored in foo, since both would fit in a sequence with a capacity for 20 characters. By convention, the end of strings represented in character sequences is signaled by a special character, a null character, whose literal value can be written as single quote, \0, single quote, open parenthesis. Numerically, this generally represents the value 0, close parenthesis. In this case, the array of 20 elements of type char called foo can be represented simply by storing the character sequences double quote, hello double quote, or double quote, Merry Christmas double quote, as simple sequences of the letters double quote, HELLO \0 double quote, or double quote, MERRYCHRISTMAS \0 double quote, beginning in the memory location that the compiler has named double quote, foo, double quote. Notice how after the content of the string itself, a null character, open parenthesis, single quote, \0, single quote, close parenthesis, has been added in order to indicate the end of the sequence. The remainder of the 20 character memory cells within double quote, foo, double quote, have undetermined values. A character sequence of this type is known as a null terminated character sequence. Initialization of null terminated character sequences. Because arrays of characters are ordinary arrays, they follow the same rules as any other array. For example, to initialize an array of characters with some predetermined sequence of text, we can do it just like any other array. If we want to store double quote, hello double quote, in a new array to be named double quote, my word double quote, we could write this statement in C++, char my word left square bracket right square bracket equals, open curly brace, single quote, H, single quote, single quote, E, single quote, single quote, L, single quote, single quote, L, single quote, single quote, O, single quote, single quote, \0, single quote, close curly brace, semicolon. The above declares an array of 6 elements of type char initialized with the characters that form the word double quote, hello double quote, plus a null character, single quote, \0, single quote, at the end. But arrays of character elements have another way to be initialized, using string literals directly. In the expressions used in some examples in previous chapters, string literals have already shown up several times. These are specified by enclosing the text between double quotes. For example, double quote, the result is, double quote. This is a string literal, probably used in some earlier example. Sequences of characters enclosed in double quotes are literal constants, and their type is, in fact, a null terminated array of characters. This means that string literals always have a null character, open parenthesis, single quote, \0, single quote, close parenthesis, automatically appended at the end. Therefore, the array of char elements called double quote, my word double quote, can be initialized with a null terminated sequence of characters by either one of these two statements. Char my word left square bracket right square bracket equals, open curly brace, single quote, H, single quote, comma, single quote, E, single quote, comma, single quote, L, single quote, comma, single quote, L, single quote, comma, single quote, O, single quote, comma, single quote, backslash 0, single quote, close curly brace, semicolon, or comma, char my word left square bracket right square bracket equals double quote, below double quote, semicolon. In both cases, comma, the array of characters to be named double quote, my word double quote, is declared with the size of 6 elements of type char colon the 5 characters that compose the word double quote, below double quote, comma, plus a final null character, comma, which specifies the end of the sequence and which, comma, in the second case, comma, when using double quotes, comma, is appended automatically. Please notice that here we are talking about initializing an array of characters at the moment it is being declared, comma, and not about assigning values to them later, open parenthesis, once they have already been declared, close parenthesis. Even though character arrays can be initialized with a hard dash, coded literal sequence, comma, the C++ language has no provision for assigning any value to a character array after it has been declared. In fact, comma, because string literals are regular arrays, comma, they have the same restrictions as these, comma, and can only be initialized when declared. They cannot be assigned a C++ value after they have been declared and or initialized. Accordingly, the following 3 expressions, open parenthesis, once my word has already been declared as above, close parenthesis, comma, would not be valid, colon. Invalid expression 1 of 3 colon my word equals double quote, by double quote, semicolon. Invalid expression 2 of 3 colon my word left square bracket right square bracket equals double quote, by double quote, semicolon. Invalid expression 3 of 3 colon my word equals, open curly brace, single quote, A, single quote, comma, single quote, Y, single quote, comma, single quote, E, single quote, comma, single quote, backslash 0, single quote, close curly brace, semicolon. This is because C++ has no provision for assigning values to entire arrays of any type. Note, comma, though, comma, that each of the individual elements of an array can be assigned a value individually. For example, comma, all 4 of these statements are valid, comma, and collectively, comma, they result in storage of an null dash, terminated string double quote, by double quote, in double quote, my word double quote, colon. My word left square bracket 0, right square bracket equals, single quote, A, single quote, semicolon, my word left square bracket 1 right square bracket equals, single quote, Y, single quote, semicolon, my word left square bracket 2 right square bracket equals, single quote, E, single quote, semicolon, my word left square bracket 3 right square bracket equals, single quote, backslash 0, single quote, semicolon. Strings and null dash, terminated character sequences. C++ is rather schizophrenic in its treatment of sequential groups of characters in memory. The basic language itself provides low dash, level support for null dash, terminated character arrays, comma, and it is commonplace for C++ programmers to use them in this form. In addition, comma, a stable, comma, mature library of related, comma, higher dash, level double quote, string class double quote, functions is also available, comma, through which such arrays are treated as text strings that can be manipulated with more powerful, comma, derived statements. Plain arrays with null dash, terminated sequences of characters are the typical types used in the C language to represent strings, open parenthesis, that is, why they are also known as double quote, C dash, strings double quote, close parenthesis. In C++, comma, even though the standard library defines a specific type for strings, open parenthesis, class double quote, string double quote, close parenthesis, comma, still, comma, plain arrays with null dash, terminated sequences of characters, open parenthesis, C dash, strings, close parenthesis, are a natural way of representing strings in the language. In fact, comma, string literals still always produce null dash, terminated character sequences, comma, and not string objects. In the standard library, comma, both representations for strings, open parenthesis, C dash, strings and library strings, close parenthesis, coexist, comma, and most functions requiring strings are overloaded to support both. For example, comma, cin and cout support both strings and null dash, terminated sequences directly, comma, allowing them to be directly extracted from cin, or inserted into cout, comma, just like strings. Consider the following 19-line program example, comma, which defines two strings forming queries that are displayed to the user via cout. The first of these, named double quote, question 1 double quote, is declared as a null dash, terminated character array. The second of these, named double quote, question 2 double quote, is declared as a string. Cin and cout are then used in identical ways with both double quote, question 1 double quote, and double quote, question 2 double quote, to prompt the user, to collect responses, and to compose an appropriate greeting to the user based on his prior responses. Note that the program anticipates two separate answers from the user, and that two small sections of memory, named double quote, answer 1 double quote, and double quote, answer 2 double quote, respectively, are declared. The first of these happens to be treated as a null dash, terminated character array, while the second is treated as a string. Both are used in exactly the same way with cin and cout. Here is that 19 dash line program : line 0, 1 of 19 / strings and character arrays. Line 0, 2 of 19, $, include left angle bracket, IOStream right angle bracket. Line 0, 3 of 19, $, include left angle bracket, string right angle bracket. Line 0, 4 of 19, using namespace std, Line 0, 5 of 19. Line 0, 6 of 19, int main, open parenthesis, close parenthesis. Line 0, 7 of 19, open curly brace. Line 0, 8 of 19, char question 1 left square bracket right square bracket equals double quote, please state your name : double quote, semicolon. Line 0, 9 of 19, string question 2 equals double quote, please tell me where you live : double quote, semicolon. Line 10 of 19, char answer 1 left square bracket 80 right square bracket, semicolon. Line 11 of 19, string answer 2, semicolon. Line 12 of 19, cout, double left arrow, question 1, semicolon. Line 13 of 19, cin, double right arrow answer 1, semicolon. Line 14 of 19, cout, double left arrow, question 2, semicolon. Line 15 of 19, cin, double right arrow answer 2, semicolon. Line 16 of 19, cout, double left arrow, double quote, hello, double quote, double left arrow, answer 1, semicolon. Line 17 of 19, cout, double left arrow, double quote, from double quote, double left arrow, answer 2, double left arrow, double quote, exclamation, \n double quote, semicolon. Line 18 of 19, return 0, semicolon. Line 19 of 19, close curly brace. When that program was run in an appropriate situation, the following output was generated: please state your name : Homer. Please tell me where you live : Greece. Hello, Homer from Greece. In this example, both arrays of characters using null dash, terminated sequences and strings are used. They are quite interchangeable in their use together with cin and cout, but there is a notable difference in their declarations. Arrays have a fixed size that needs to be specified either implicitly or explicitly when declared, semicolon. Question 1 has a size of exactly 20 characters, open parenthesis, automatically calculated by the compiler due to the length of the hard dash, coded text string, including the terminating null dash, characters, close parenthesis, and answer 1 has a hard dash, coded size of 80 characters, semicolon, while strings are simply strings, no size is specified. This is due to the fact that C++ strings have a dynamic size determined during runtime, while the size of arrays is determined during compilation, before the program runs. In any case, null dash, terminated character sequences and arrays are easily transformed from one another. Null dash, terminated character sequences can be transformed into strings implicitly with a simple assignment statement, and strings can be transformed into null dash, terminated character sequences by using a member function of the C++ string class. For example, here is a 4-line code snippet showing direct conversion of a character sequence to a string via a single assignment statement containing an equals sign, and also showing two different ways of printing the resulting string with cout. In the first case, cout takes its input directly from the string named double quote, my string double quote. In the second case, cout takes its input, as if my string were a character array, through the member function named double quote, my string point C_str double quote. Line 0, 1 of 0, 4, char character array 1 left square bracket right square bracket equals double quote, some text double quote, semicolon. Line 02 of 04 string my string equals character array 1, semicolon / convert C dash, string to string. Line 03 of 04 see out, double left arrow, my string, semicolon / printed, as a library string. Line 04 of 04 see out, double left arrow, my string point C underscore str, open parenthesis, closed parenthesis, semicolon / printed, as a C dash, string. Further details about classes and member functions will be covered in a later section of this training.